Hi, this is Xavier with BioTek. Today I'm going to be talking to you about the Lionheart FX automated microscope. I'm going to describe a little bit to you how this system works and what it does, and then I will describe some of the key applications more in detail. First of all, Lionheart FX is an inverted fluorescence microscope. If you look at the system itself, what you will see is that here you have access to filter cubes to select your colors. There is a 6 objective automated turret right there. The system comes with an incubation chamber that you can use for live cell assays that will control temperature, gases and humidity. There is an automated stage right here in which you can put any kind of samples such as slides and chamber slides like this. You can also run your cell culture dishes and of course microplates. Even though Lionheart FX is an inverted microscope, it can actually do a lot more for you. At BioTek, that's what we call augmented microscopy, which is about the integration of the hardware and the software to give you a very powerful solution, and that's what I'm going to describe to you right now. So let me show you what augmented microscopy can do for you, the combination of automated microscopy and software. You can see here a simple application, cell proliferation, that is fully analyzed by the system. The system images in bright field. The images are processed as a movie. It is a live cell assay. And then the system will analyze all of the images in the movie to draw a confluence mask. Based on this, the system will draw kinetic curves. Here you can see the cells proliferating with the mask and the kinetic analysis. Even more powerful, what the system can do is label-free cell counting, which is an example here. Same assay, cell proliferation, but what you can see here is the system doing bright field acquisition of images. Then the images are processed to increase the contrast of your images, and based on that you can do a cell count. Now you have an actual cell count to do your kinetic analysis, which is going to give you very precise cellular information. Here you can see the movie of the processed image, very high contrast, with a cell count and your kinetic analysis. Here's another example of what you can do with an automated scope. Because it's automated, if you want to image large samples like an entire well, the system will automatically tile your sample and then stitch all of these tiles together, analyze the stitched image to find your objects of interest, and then perform analysis on this data and plot your curves. Another example of application is when you work on 3D samples. Since the system has autofocus, you can do Z-stacks of here tumor spheroids. Over time, the system will create a movie over time of your Z-projected spheroids, analyze these images, as you can see here, for apoptosis and necrosis in an example, and then plot the course of apoptosis and necrosis over time. You can see here a movie done on one spheroid. Green is apoptosis, red is necrosis, analysis, and time course. This is done in an entire microplate automatically at a time. In this example, I want to highlight the fact that the system can come with automated injection, which is very useful for applications such as calcium kinetics. What you can see here is, again, working on an entire microplate, the system will inject a trigger on your cells, create a movie showing you what happens at injection, and then analyze the images to give you quantitative data on what's happening with your cells. Here you see the baseline, injection, reaction, the cells react, and then you can see what happens over time to your cells. And that is because of the system's automated injection system. Finally, one slide to show you that you can do very advanced cellular analysis with this system. What you can see here is an example of an autophagy analysis using object spot counting. Your cells are imaged at 20x. They are then processed so that your little autophagosomes are better visible. These images are then analyzed by the system automatically. The cells are segmented and the autophagosomes are automatically detected and counted. The machine can count them and also measure their size. Each of these little objects is actually sub-micron in terms of size. You can see here a cell, you can see the nucleus, and you can see your autophagosomes. So in summary, this is what Lionheart can do for you. It combines automated and augmented microscopy, which will really accelerate your research and greatly increase your productivity. Thank you very much for your time. Have a good day. If you want more information on this product, please go to biotek.com.